So next I am going to show you the continuation for the assignment in center of mass and conservation of linear momentum. Earlier I have shown you 30 questions, question number 1 to question number 30. In the assignment in center of mass and conservation of linear momentum, I have given you the answers for all the questions, and I have also given the explanations or solutions for all the questions. Next, I am going to show you the continuation part for the earlier part of the assignment. So you can get ready with your pen and notebook. Now I am going to show you in this class, I will be just showing you the questions numbering from 31 to 61 on the screen, one after another. So I will not be discussing the solutions of these questions in this class. So I will be just showing the questions one after another. In the last, I will be also showing you the answers for these questions. So after each question, I may just give you little gap to answer the question, or little time gap, which may not be sufficient for many students. But in case you need more time to answer the question, you can take a pause and take your own time to answer the question. Come on, look at the screen here. Look at the question number 31. A trolley of mass 360 kg is lying on a horizontal frictionless surface. A man of mass 40 kg runs with uniform speed on the trolley by a distance of 2 meters in 0.5 seconds. What is the velocity of the trolley relative to the earth? I've shown 4 options on screen. Come on, try this question. This question was originally given in one of the previous MSET exam papers, also in one of the All India entrance examinations. In case you need more time to answer this question, you can take a pause and take your own time. I am going to show the next question on the screen. Look at the question number 32. Two particles of masses m1 and m2 in projectile motion have velocities u1 bar and u2 bar, respectively at time t equal to 0. They collide at time t naught. Their velocities become v1 bar and v2 bar at time 2t naught while still moving in air. The value of modulus of m1 v1 bar plus m2 v2 bar within brackets minus within brackets m1 u1 bar plus m2 u2 bar is. So there are 4 options on screen. Come on, try to answer the question. This question was given in one of the previous IIT JEE exam in for screening test. So in case you need more time to answer the question, you can take a pause and take your own time. I am going to show the next question on the screen. Look at the question number 33. I am going to read the question. A man of mass small m clings to a rope ladder suspended below a balloon of mass capital M. The balloon is stationary with respect to the ground. Part of the question. If the man begins to climb the ladder at a speed v, within brackets with respect to ladder, in what direction and with what speed, within brackets with respect to the earth, Will the balloon move? Part B of the question, what is the state of motion of the after the man starts climbing? Come on, start trying this question. In case you need more time to answer this question, you can take a pause and take your own time. I am going to show the next question on screen. Look at the question number 34. A block of mass small m is placed on the top of a bigger block of mass capital M as shown. All the surfaces are frictionless. The system is released from the rest. Find the distance moved by the bigger block at the instant the smaller block reaches the ground. Your answer should be expressed in terms of capital M, small m, and capital L. Here capital L is the length of the base of the bigger block of mass capital M. Come on, try the question. In case you need more time to answer the question, you can take a pause and take your own time. I am going to show the next question on the screen. See the question number 35. A man of mass small m is standing on a platform of mass capital M, kept on smooth ice. The man starts moving on the platform with speed v relative to the platform. With what velocity relative to the ice does the platform recoil? Come on, try the question. This question is also given letter rotation. So your answer should be expressed in terms of capital M, small m, and v. No multiple choice options given here. So in case you need more time to answer the question, you can take a pause. Take your time. I am going to show the next question on screen. So look at the question number 36. Projectile is fired at a speed of 100 meters per second, an angle of 37 degrees above the horizontal. At the highest point, the projectile breaks into two parts of mass ratio 1:3. The smaller mass falls freely from rest. Find the distance from the launching point to the point where the heavier piece lands. Come on, try the question. Same model work question was given one of the previous IISS entrance exam papers. Probably I think with same values. In case you need more time to answer the question, you can take a pause and take your own time. I am going to show the next question on screen. Look at the question number 37. A bomb of mass 16 kg explodes into two pieces of masses 4 kg and 12 kg. The velocity of 12 kg mass is 4 meter per second. The kinetic energy of the other mass is. Come on, try the question. You have to assume that the 16 kg mass is originally at rest. In case you need more time to answer this question, you can take a pause and take your time. I am going to show the next question on screen. See the question number 38. A body of mass small m at rest explodes into three masses, two of which of mass m by 4 each are thrown in the perpendicular directions with velocity 3 meter per second and 4 meter per second respectively. The third piece will be thrown with velocity. There are 4 options on screen. First option 3 meter per second. Second option 2.5 meter per second. Third option 2 meter per second. Fourth option 1.5 meter per second. Come on, try the question. In case you need more time to answer the question, you can take a pause and take your own time. Look at the next question. That is question number 39. A shell is fired from a cannon with velocity v at an angle theta with the horizontal direction. At the highest point on its path, it explodes into two pieces of equal mass. One of the pieces retraces its path to the cannon. The speed of the other piece immediately after the explosion is. Come on, try the question. We are shown 4 options on the screen. In case you need more time to answer this question, you can take a pause and take your own time. I am going to show the next question on the screen here. See the question number 40. A toy projectile is made of 2 parts of equal mass, which can be forced apart in flight by a light spring. The projectile is moving forward horizontally at 4 meters per second. When the spring pushes it apart, one half goes vertically downwards, with initial velocity 6 meters per second relative to the ground. The speed of the other half is. Come on, try the question. Now, you may need more time to answer the question. Therefore, you can take a pause and take your own time. I am going to show the next question on screen. Look at the question number 41. A gun fires a bullet of mass 50 gram with a velocity of 30 meters per second. Because of this, the gun is pushed back with a velocity of 1 meter per second. The mass of the gun is. Come on, try the question. There are 4 options shown on the screen. In case you need more time to answer the question, you can take a pause and take your own time. I am going to show the next question on screen. See the question number 42. So look at the next question, question number 42. Find the coordinates of center of mass of the L-shaped frame of wire. So you have to assume that the wire has uniform thickness and density. That is uniform mass per unit length. X-axis is taken along towards right shown in the figure. The length of the wire along x-axis L by 4. The length of the wire along y-axis 3L by 4. The wire has uniform linear mass density. That means uniform mass per unit length. You have to find the answer in terms of L. That means you have to find the coordinates x, y of the center of mass of the frame, L-shaped frame of wire in terms of L. Come on, try the question. In case you need more time to answer the question, you can take a pause and take your time. I am going to show the next question on screen. See the question number 43. A man weighing 80 kg standing on a trolley weighing 320 kg. The trolley is resting on frictionless horizontal rails. The man starts walking on the trolley along the rails at a speed of 1 meter per second. Then after 4 seconds, his displacement relative to the ground will be. Come on. Start trying the question. In case you may need more time to answer the question, you can take a pause and take your time. I am going to show the next question on screen. See the question number 44. A particle of mass 4m which is at rest explodes into 3 fragments. 2 of the fragments, each of mass m, are found to move at a speed v each in mutually perpendicular directions. The total energy released in the process is. Come on, try the question. I have shown 4 options on the screen. So probably you'll need more time to answer the question. You can take a pause and take your own time to answer the question. I'm going to show the next question on the screen. See the question number 45. For particles of masses m, 2m, 3m and 4m are at the vertex of a parallelogram in the xy plane with one of adjacent angle 60 degrees and smaller a and smaller side a and larger side to a. The mass m is at origin and mass 4m on the x-axis. The center of mass of system is. Come on, try the question. Look at the question number 46. Masses 8, 2, 4, 2 kg are placed at the corners capital A, capital B, capital C and capital D respectively of a square ABCD of diagonal 80 centimeter. The distance of center of mass from A will be, that means from the first corner here. That means center of mass system of 4 masses. Come on, try the question. In case you need more time to answer the question, take a pause and take your time. I am going to show the next question on the screen. Look at the question number 47. Two bodies of mass 2 kg and 4 kg are moving with velocities 2 meters per second, 10 meters per second towards each other due to mutual gravitational attraction. And the velocity of center of mass will be. Come on, try the question. That means you are given the magnitude of velocities of the two masses which are directed towards each other. You have to find magnitude velocity center of mass of the system of the two masses. So in case you need more time to answer this question, you can take a pause and take your time. I am going to show the next question on screen. See the question number 48. 3 identical spheres each of mass 3 kg are placed touching each other with their centers lying on straight line. The centers of spheres are marked as P, Q and R respectively. The distance center of mass system from P is. Come on, try the question. In case you need more time to answer this question, you can take a pause and take your time. I am going to show the next question on screen. See the question number 49. A hole of radius small r by 2 is cut in a disk of radius small r having mass m. The center of mass of the system will be. The new position of center of mass of the disk, remaining disk. There are 4 options here. First one at center, second one option at distance r by 3 from center, away from the hole along the common diameter. Third part to the third option, at distance r by 4 from center away from the hole along the common diameter. Fourth option, at distance r by 6 from center away from the hole along the common diameter. Come on, try the question. In case you need more time to answer the question, you can take a pause and take your time. I am going to show you the next question on screen. See the question number 50. 3 identical bricks of length small l are placed on the top of each other as shown in the figure, so that the path of each overhangs the one below. Find in terms of length L the maximum value of total overhang X. Here L is the length of each brick. There are 4 options screen. Come on, try to answer the question. You can take a pause and take your time to answer the question. Probably most of you need more time to answer the question. You can take a pause and take your own time to try the question. I am going to next show the next question on the screen. See the question number 51. Rod of length capital L is non-uniform. Its linear density, mass per unit length, varies linearly with distance from left end. Then its center of mass from the left end is at a distance. The linear density at left end may be taken as 0. So you are shown 4 options on the screen in terms of capital L. Come on, try the question. Definitely you may need more time to answer this question. You can take a pause and take your own time. So next I am going to show you the next question on screen. Look at the question number 52. In the following diagram, the small prism of mass capital M slides down on the bigger prism of mass 5m. From the position shown at the top of the bigger prism to the position at the bottom of the bigger prism, as shown in the figure. By what distance the combination moved to the left, the bigger prism initially rests on a frictionless floor. So I'll be showing you the diagram next slide. Once you look at the diagram, the bigger prism has mass 5 into capital M, smaller prism has mass capital M. Length of the bigger prism, the 2 perpendicular length of each one of the 2 perpendicular edges of the bigger prism is 5L and 5L each. Length of each one of the 2 perpendicular edges of each small prism is L. So again I show the question back. So come on, can copy the diagram and try this question. That means you have to assume that the system is released from rest and all the surfaces are frictionless. The bigger prism rests on a smooth harried surface. When you have to find that horizontal distance which with the bigger prism moves to the left side when the smaller prism moves to the bottom of the incline. Bottom of the inclined surface of the bigger prism. In case you need more time to answer this question, you can take a pause and take your own time. I am going to show you the next question on screen. I have shown first multiple choices for this question. First option L by 5, second option 2 L by 3, third option 4 L by 5, fourth option L by 6. In case you need more time, you take a pause and take your own time. I am going to show the next question on screen. See the question number 53. A thin rod of length capital L is lying along x-axis with its ends at x equal to 0 and x equal to L. Its linear density, mass per unit length, varies with x as k into x by L whole power n, where n can be 0 or any positive number. The position axiom of center of mass of the rod is plotted against small n. Which of the following graphs best approximates the dependence of axiom on n? I will be showing the 4 graphs now, but before that, first you copy this relation. That is, mass linear density varies with the distance x from one of the ends as k into x by L power n. Copy this relation first. Next, I am going to show the 4 options. You have to find out which one of these 4 graphs is correct. Definitely, you may need some time to try the question. You can take a pause and take your own time. I am going to show the next question on screen. See the question number 54. A person of mass capital M equal 90 kg standing on a horizontal plane of ice throws a body of mass small m equal 10 kg horizontal on the same surface. The distance between the person and the body after 10 seconds is 10 meters. The kinetic energy of the person in joules is. You have shown 4 options screen. Come on, try the question. This question was originally given 2008 MSET, the medical entrance. In case you need more time to answer this question, you can take a pause and take your time. I am going to show the next question on screen. See the question number 55. 2 carts on horizontal straight rails are pushed apart by an explosion of a power charge capital Q placed between the carts. The coefficients of friction between the carts and the rails are identical. The 200 kg cart travels 36 meters and stops. What is the distance covered by the cart weighing 300 kg? Come on, copy the figure and try this question. This question was also given one of the previous entrance examinations in the All India medical entrances. I think it's CPMT. That means you have to assume that these 2 masses are originally at rest. After explosion of this Q, they start moving in opposite direction with velocities of magnitudes denoted by V1 and V2. In case you need more time to answer the question, you can take a pause and take your own time. I am going to show the next question on screen. See the question number 56. Two bodies, the two bodies of mass M1 and M2 within brackets M1 greater than M2 respectively are tied to the ends of a string which passes over a light frictionless pulley. The mass are initially at rest and then released. The acceleration center of mass is, you are given 4 options in terms of G and the two masses M1 and M2. You can take a pause and take your own time to answer this question. I am going to show you the next question on screen. See the question number 57. Look at the drawing given in the figure, which has been drawn with ink of uniform line thickness. The mass of ink used to draw each one of the two inner circles and each one of two line segments is small n. The mass of the ink used to draw the outer circle is 6m. The coordinate centers of the different parts are the outer circle 0, 0, left inner circle minus a, a, right inner circle a, a, vertical line 0, 0, and 0, minus a. The bicoordinate center of mass ink in this drawing is, come on, try the question here. This question was given one of the previous IIT entrance examination paper. Probably most of you may need more time to answer the question. You can take a pause and take your own time to try the question. I am going to show the next question on screen. See the question number 58. An isolated particle of mass m is moving in horizontal plane xy, that means xy plane, along the x-axis at a certain height above the ground. It suddenly explodes into two fragments of mass of m by 4 and 3m by 4. At an instant later, the smaller fragment is at y equal plus 15 centimeters. The larger fragment at this distance, at this instant, is at. You have shown 4 options on screen. Come on, try the question. This question was also given in one of the previous IIT JEE entrance exam papers, 1997. You can take a pause and take your own time to try this question. I am going to show the next question on screen. See the question number 59. Small sphere of radius r is held against the inner surface of a large sphere of radius 6r. The mass of large and small spheres are 4m and m respectively. This arrangement is placed on a horizontal table. There is no friction between any surfaces of contact. The small sphere is now released. Find the coordinate center of the large sphere when the small sphere reaches the other extreme position. Come on, try this question. You can take a pause and try the question yourself. This question was also given one of the previous JEE examination. I am going to show the next question on screen. See the question number 60. Statement 1. There is no external torque on a body in isolated. If there is no external torque on a body, about its, if there, just look at the question number 60. Statement 1. If there is no external torque on an isolated body about its center of mass, then the velocity center of mass remains constant. Because, look at the statement 2. The linear amount of an isolated system remains constant. You have to mark option A as your answer if statement 1 is true. Statement 2 is also true, and statement 2 is the correct explanation for statement 1. You have to mark statement B. You have to mark your answer as B. If statement 1 is true, statement 2 is true, but statement 2 is not a correct explanation for statement 1. You have to mark your answer as C if statement 1 is true and statement 2 is false. You have to mark your answer as D if statement 1 is false and statement 2 is true. In case you need more time to answer this question, you can take a pause and take your time. I am going to next show the answers for all these questions on the screen so that you can check up your answers. See the answers on the screen. First, I have shown the answers for questions numbering 31 to 38. For question number 31, second option is answer. For question number 32, third option is answer. For question number 33, part A, down, and the magnitude of velocity small m into capital V by capital M plus small m. For part B of the question, stationary. For question number 34, answer is small m into capital L by capital M plus small m. For question number 34, answer is small m into capital V by capital M plus small m. For question number 35, third option is answer. For question number 36, fourth option is answer. For question number 37, second option is answer. For question number 38, first option is answer. In case you need more time to copy these answers, you can take a pause. Look at the answers for the next questions here. So look at the answers here one by one. First, I have shown the answers from questions numbering 31 to 39. You can copy the answers or check up your answers. I will once read out these answers. For question number 31, second option is answer. For question number 32, third option is answer. For question number 33, part A of the question, down, and magnitude of velocity required is small m into capital V by capital M plus small m. That is magnitude of velocity with which a balloon moves, and balloon moves in the downward direction. And for part B of the question, stationary. That is the balloon remains stationary. For 34th question, answer is small m into capital L by capital M plus small m. For question number 35, answer is small m into capital V by divided by capital M plus small m. For question number 36, third option is answer. For question number 37, fourth option is answer. For question number 38, second option is answer. For question number 39, first option is the answer. For question number 40, fourth option is answer. For question number 41, third option is answer. For question number 42, answer is L by 32, 9L by 32. For question number 43, second option is answer. For next three questions, 44, 45 and 46, third option is answer. For next two questions, 47 and 48, second option is answer. Next, I have shown the answers from 49 to 58 on the screen. For question number 49, fourth option is answer. For question number 50, third option is answer. For question number 51, fourth option is answer. For next two questions, 52 and 53, third option is answer. For 54, first option is answer. For next two questions, 55 and 56, third option is answer. For next two questions, 57 and 58, first option is answer. So you can mark all your answers up to question number 58 as shown on the screen. In case you need time, you can take a pause. The next time showing the answers for the last two questions, 59 and 60 on screen. For 59th question, answer is capital L plus 2 capital R comma 0. That means coordinates the center of coordinates, required coordinates. Question number 60, fourth option is answer. In my next class, I will be discussing the solutions of these questions.